Alright, Assalamualaikum everyone. Welcome to lesson number 4 of basically organic chemistry. Is organic chemistry. We are doing nomenclature for now, and to this very extensive lesson, I'm adding one more part, which is going to be focused on carboxylic acids. So once again, the rules are in front of you. There's only a slight difference over here, which you need to be careful about. And that slight difference is that in this case, wherever you see this COOH group in any molecule, you can identify that as a carboxylic acid. And other than that, once you have identified something as a carboxylic acid, whenever we name it, the suffix is anoic acid. So we'll do some examples like ethanoic acid, propanoic acid, butanoic acid, and so on and so forth. Now, in this case, because we have now there's one important thing to note over here. In this case, what is your functional group? Your functional group is a carbon, has a carbon in itself, right? This carbon over here is part of the functional group, and it's also going to be part of the longest carbon chain. Let me show you how. So for example, if I have this molecule right over here, CH3, CH2, COOH, and if someone asks me, well, what is the longest carbon chain over here? This is our longest carbon chain. Now, can you see that in all of the previous cases that we were doing, because in their functional groups we were talking about all other atoms other than carbon, we just used to go up till the point where we used to go up till the carbon where the functional group was attached. But over here, the functional group in itself has a carbon. And so whenever you have such cases, remember that in the longest carbon chain, you will include the carbon of the functional group. And so you can see there are 3 carbons here. So this will definitely be propan, or you can say it's prop, all right? And because it's an acid, I can identify it as an acid. It's going to be propanoic acid. So there's one very important part to remember. Whenever you give a name to a carboxylic acid, remember that this initial part, as we know, tells us about the number of carbon atoms in the longest carbon chain. Remember that this will always include, it will include this functional group carbon always. So keep that in mind. If you have already, you've already done this in O levels, I'm pretty sure this is something that you were already aware of. If not, then please practice this and keep this in mind. And this is the reason why we say that the carboxyl group carbon is given the highest preference. So the carboxyl group, which is basically right over here, this carbon over here is given the highest preference. So whenever you're going to be numbering this, the longest carbon chain, you will notice that this carboxyl carbon will always get number 1. Why? Because in any given compound, this COOH is a terminal group. It will always come at the end. And so when we are giving it the highest preference, it will always get a 1. So in this case, I get a 1 over here, 2 here, and 3 here. And that is why we don't really need to worry about the numbering in carboxylic acids, because the carboxylic acid will always come at the end of the chain, and therefore the functional group in itself always gets number 1. And that's why we don't usually worry about the numbering. However, let's do a few examples and perhaps it will get more clear. So in the first example, again, it's a skeletal formula, and I did that by intention because I want you to become more and more familiar with and comfortable with this kind of a formula, the skeletal formula, I mean. So in this case, as I said, the edges, your vertex are your carbons, my bad. So you have 1 carbon, 2 carbon, 3, and 4. Now remember that this is a carbon, all right, to which a double bond O is attached. All right, this is a carbon, don't ignore it. So I can see that I have 4, I have 4 carbons over here. So this will be but, all right. And because I can identify that I have this COOH bond over here, this is the carboxylic acid group. And so I know this is going to be butanoic acid. And that is going to be the name of this molecule. Let's look at the second case. Now in this case, you can see now we have further 1 carbon, 2nd carbon, and this is our 3rd carbon. In this case, this is going to be prop, And because I can see that it has a carboxylic acid group, so it's going to be a carboxylic acid. So the naming or the suffix is going to be propanoic acid. Remember that the prefix comes from the number of carbon, you count the longest carbon chain and that gives you the prefix, and the functional groups gives you the suffix. And in this case, when you identify the functional group as a carboxylic acid group, the suffix is going to be an anoic acid. All right, let's do example number 3. All right, in example number 3, as always, I'll draw the vertices for you. So this is 1 2 3 4 5 6 7. But what is the longest carbon chain over here? 1 2 3 4. All right, 2 3 4, and that's it. My bad, I accidentally labeled this as a vertex. No, it is a vertex, but it's not a carbon. The atom attached over here is an oxygen, it's not carbon. So now in this case, what you see is that although you have 1 2 3 4 5 6 carbons, but your longest carbon chain has 1 2 3 4 5 carbons. And that is why it's going to be pent. And because I see this group right over here, this carboxylic acid group, I'm going to name it as pentanoic acid. Now, like in all other cases, like in the cases of, in the case of alcohols and alkyl groups, you will, pay attention to these alkyl groups later on. After you have named the molecule, then you worry about these methyl, ethyl, and other groups. Now we already know, or I hope you already know from the previous videos, that this is a methyl group. When nothing is mentioned and we just have a line extending from a certain carbon, it is a methyl group. So now we need to kind of number this carboxylic acid, all right, because we need to mention the position of the methyl group. Now in this case, look over here. So I can number it like this, and we remember that the carbon with which is basically the carboxyl group, that carbon is given the highest preference. So 1 2 3 4 and 5. So to which carbon is the methyl group attached? Number 2, right? And so when we are naming this, I'm gonna say 2-methyl pentanoic acid, and that's the name of this molecule. I hope this is getting clear to you guys. Let's try out another example. This is a straightforward one. So in this case, you can see you have 1 2 and 3 carbons, and so I'm going to name this as prop. And because I see a this carboxylic acid group COOH, I'm going to say this is propanoic acid. And now because I see this Cl as well, this chlorine, I need to now mention the position of this chlorine as well. Now for that, again, I have to number this molecule. So 1 over here, 2 and 3 over here. So now I can see that this chlorine is attached to the third carbon, and so this will be 3-chloropropanoic acid. If you have watched all of my previous videos, whatever I'm doing right now would be absolutely clear to you. At least that is my expectation, because we have already done this very extensively when we were doing haloalkanes. All right. Okay, now one important thing that I would like to mention over here is that this COOH group gets a higher preference than OH, gets higher preference than C export, and gets higher preference than your alkyl groups. All right, and this is the reason why I did not name this. I didn't first go and look at the carbon with which chlorine was attached. I first named this molecule as if it was just a carboxylic acid. So this is because of this hierarchy that your carboxylic acid group is given higher preference than the OH, and it is given higher preference than the haloalkane bonds, and it is given higher preference than the alkyls. And we have already seen how, if I were to actually replace this, I can also say that this alcohol and haloalkanes, we already know, are given higher preference than the alkyls. And so I can actually mention this as this. The fact that COOH, or the carboxylic acid group, is given higher preference over the OH and the CX bonds, or the Yeah, and that is given higher preference than the alkyls. All right, the last example is an interesting one. Over here we have a cyclical compound involved. We have already seen how to name our cyclical compounds as well. So let me quickly point out the vertices. So 1, 2, 3, 4, 5. And so this tells me that this thing right over here is cyclopentane. If you don't know how to name such molecules, you should watch my video on the nomenclature of alkanes, and hopefully this will get clear. So it is cyclo because it's a cyclical compound, it's enclosed, there were 5 carbons involved, so I said it's cyclopentane. Now with this cyclopentane, what we see is that a carboxylic acid group is attached. And so whenever this happens, all you have to do is that once you are done writing cyclopentane, all you have to do is you need to write carboxylic acid, and that's all you need to do. All right, so end this cyclopentane with carboxylic acid. All right, so in this case, realize that the longest carbon chain, it's not really about the longest carbon chain, it is about this cyclical structure. All right, and even if we're not usually talking about the longest carbon chain when it comes to cyclical structures. We are just talking about the carbons which are involved in that cyclical structure, and there were 5, so I named it as cyclopentane. Now you might be wondering, why didn't we label this as 1, 2, or 3 something and specifically say, oh, this is 1 carboxylic acid or something like that? Well, that's because it doesn't really matter now. It doesn't really matter where the carboxylic acid group is attached. So for a minute, just imagine if the carboxylic acid group was attached over here and it wasn't over here, I could still say this is 1 and give it higher preference. If the carboxylic acid group was not here, if let's say it was here, I could still say that this is number 1, right? This carbon with which the carboxylic acid group is number 1. So the point at the end of the day is that it is still always going to be at number 1 position. And so when you have just one substituent in your cyclical structures, we don't really number them. We just say cyclopentane, carboxylic acid. And what that means is that you first draw a cyclopentane and then you just attach a carboxylic acid group, and that's all you need to do. So this was for carboxylic acids. I hope the video made sense to you. If it did, then give it a big thumbs up, subscribe to the channel, and hit the bell icon. In case of any queries, you can always put them down in the description, in the comments below, and I'll definitely would love to answer them for you. I'll see you next time. Khuda Hafiz.